The first unit test that we're going to discuss is our function relationships test. I'm going to begin with 1 through 5, determine if the relation is a function, and explain your reasoning in each case. When we look for functions, we want functions to, in a graph, pass what we call the vertical line test, where if our pencil or our vertical line hits more than one place on that graph, it's not a function. In this case of number 1, yes, this is a function. It passes the vertical line test. And that means every x value only has one y value. Every x value only has one y value. I'm going to go on to number 2. Number 2 is not a graph, so we have to use the definition of a function. And a function is a relation when every x only has one unique y. I look at -1, it only has one y value with it. I don't see -1 anywhere in the x list. I look at 9, it's got one y value. I look at 12, it's got one y value. I look at 15, it's got just one y value. None of my x's are repeated. They all have one y value with them. So this is a function. Each x value has a unique y value. Let's say it has only one y value. Only one y value. Now, one thing that you might pick up on here is the fact that -7 is a y value that shows up twice. That's not an issue. Y is repeated, no problem. X is repeated, on the other hand, that's when it's not a function. So we go down to number 3. I look at my x's. Are there any repeats in x? There's not. This is a function. And this explanation you can write out as same as number 2's explanation. Write out what we did for 2. What I'm going to look at next for number 4, it's in a graph. I want to pass my pencil or my vertical line across. And in the case of number 4, this one is not a function. It does not pass the vertical line test. And if I wanted to have an example to show why, I could go, all right, well, when x is, let's go out here to 3. You see when x is 3, it's got a y value of 2. It's also got a y value of -2. There's the problem. I could actually find other places where the x value has 2 different y's all the way along. Last but not least, is this a function? We have a distance runner running 750 meters at a time. Her coach records the distance covered every 20 seconds. The results of one run are presented in the table. Look across at your times. Do our times of 0 seconds, 20, 40, 60, 80, 100, I have nothing repeated. So all of our times, so it is a function, all of our times have a different distance.